If I'm in y'all's way, y'all tell me. Alright. Yes. Number 1 is in factor form. We love it when stuff's in factor form. But also to multiply that out, what kind of function would that be? Quadratic, because x times x is what? X squared. Okay. So the first thing you're going to do is find your zeros. What's your zeros here? Oh, positive 1 and negative 3. Alright, so you're going to draw like a little number line. And you can put negative 3 and positive 1 on there. And you're going to sketch the graph on this number line. Yes, I know I don't have an x and y coordinate, but I just want you to sketch the graph, okay? If this is quadratic, my leading coefficient is what here? Positive. So it would go something like this, wouldn't it? If I sketched the graph, wouldn't it? Because that's where it crosses the x-axis. Do y'all agree? Okay. That's the hardest part. That's the hardest part of the problem. So if you got that so far, you're good. Now, pay close attention to that right there. What does that mean? Less than what?
0.
Where on that graph is it less than 0? So right here when it goes below the x-axis, isn't it? So that's your answer, your part of your answer. So you say, okay, so Mr. how do I write that? Okay. You're going to put in interval notation. Negative 3, comma 1. Go back to the original. Is that less than or less than or equal to? So what do you think you put around both of these? That's your answer. If it had been less than or equal to, that would have been bracket because these numbers make it equal to 0, don't it? But because it doesn't have or equal to 0, that's why I put parentheses around them. Does that make sense? Okay, let's look at number 2. It's not in factor form. So I'm going to put it in factor form. So what would I take out of that? Okay, what's my zeros here? And x equals what? 3. So I'm going to come over here. Now go back to my original. What type of function is that? Quadratic. My leading coefficient is? Positive. So it's going to be, both my ends going to be sticking straight up. I want it greater than. So where would it be greater than from? What? Negative infinity to 0 union 3 to what? Infinity. Because you don't want the less than 0, do you? You want greater than 0. Does that make sense? You want the part that's above the line. Because that line, the line is at 0, isn't it? You want it greater than 0, so it's going to be above. So I would write that. Negative infinity to 0, bracket because it's got greater than or equal to, union 3 to infinity. That is my answer for that particular problem. You saying why is number 1 not negative infinity? Because I want the part that's less than 0, and the part less than 0 is below the line, and it's below the line from negative 3 to 1.
You're trying to find the range, basically?
Yes. Number 3. First of all, what type of function is that going to be? Quadratic. What? Okay, you said, okay, how do you tell the leading coefficient? Great answer. The leading coefficient is always the number in front of the variable with the largest exponents. Even though 16 appears first, your leading coefficient is negative 1 because it goes in front of x squared. So both your ends will be sticking straight what? Down. Okay, so this is difference of squares. 4 plus x, 4 minus x. So x equals negative 4, x equals 4. Now, you always gotta look. I didn't have any multiplicities there. I didn't have anything squared there. Because if you do have something squared, you remember you got to do your bump. Or if you have your odd multiplicity, you got to do your break. So you got to keep all that in mind. We hadn't ran into an example like that yet. All right, so I'm going to go like this. it wants it greater than 0. Where does it appear to be greater than 0? From -4 to what? Because it's above the line. Now go back to the original problem. It's greater than. So would I put parentheses or bracket around those? And that's your answer. That is how we do regular linear inequalities. Solve it like an equation. Nonlinear, you have to draw the picture of the graph to be able to tell it, okay? Alright, number 4. It's got to be set equal to 0, just like an equation. So I'm going to move the 5 over. So I got 2x squared plus 3x minus 5 less than equal to 0. I'm going to factor it. Use a misgesture. What if they don't factor? I'm not going to give you one of these that don't factor. So they're going to factor. Alright, do your factoring method. Make sure you got 2x plus 5 and x minus 1 when you factor that. Alright, so let's go back to what type of function is that? Quadratic, and the leading coefficient is what? Positive. I know with my ends going to be sticking straight up. Alright, so I set these equal to 0. I get x equals -5/2 and x equals 1. So if I draw my little picture here, I want it less than or equal to what? 0. Alright, where's it less than or equal to 0 at? Between -5/2 and... What would I put behind around -5/2 and 1? Bracket. Very good. These are not too bad, are they? Yes.
So you wouldn't worry about the original equation whenever it says 5?
No. You go to where it's 0. Alright, number 5. Let's talk about what type. If I multiplied x times x squared, what would that give me? X cubed. So remember, it's going to be a different shape, isn't it? It's a leading coefficient positive, so it means it's going to go like this, isn't it? Okay? Alright, so let's look here. Now, this is already factored, but I can factor that down to x plus 3 what? Squared. Oh, that multiplicity is coming here, isn't it? The bumping of the graph. So I got x equals 2 and x equals -3. So now I have a dot there and a dot there. At -3, I bump the graph. I only want it where it's greater than 0. Where would that be at? What interval would that be at? And what goes around 2? Very good. That's your answer. Alright, number 6, I'm going to get it set to what? 0. What can I take out of that? So it's x equals 0 with multiplicity of 2. X equals 4. It is a cubic. Your ends stick in the opposite direction. At 0, I bump the graph. Once again, it's greater than 0. Where's the greater than 0 at? And what goes around 4? Bracket. Very good. And let me just show you why this is why it is. And why, Tyler, you asked, do you have to go back to the original? You can use this one because you get the same thing. Let's pick a number to 0. What's left of 0? Negative 1. What's negative 1 cubed? Negative 1, isn't it? Negative 1 squared is 1. 4 times 1 is. Is that a true statement? No. Negative 1 is not greater than or equal to 4, is it? No. So that's why this region is not part of your answer. You pick in the regions that make it true. If I plug 1 in right here, from between 0 and 4, what's 1 cubed? What's 4 times 1? Is 1 greater than 4? That's why that region is not your answer. It makes it false. This is the only region where the numbers that's from that region makes that true. Does that make sense? Yeah. Alright, are we good on like quadratic and cubic? Okay. Those are the easy ones. Now we're about to do the 2 rational, which require more work, okay? Yeah, they are different, so you got to make sure you know what to do when it's rational and all that. Alright. First thing you do, you got to find the 0. What's the 0 on number 8? Like, if I set this equal, what's the one number I can't plug into the universe in this from the universe? 5. So x equals 5. Now, this is where you start to learn this. When you're finding the answers to these, you know we normally only worry about the denominator in these, the ones that make this equal to 0. But in order to do these problems, you have to worry about the numerator too. Okay? So you not only set the denominator equal to 0, but you got to set the numerator equal to 0 just on these types. Okay? Just on these types. Now, when we graph them, we don't have to do that. But on these, you have to set the numerator equal to 0. So if I set the numerator equal to 0, I get x equals 2, don't I? Those are the 2 numbers that you're going to put on your number line. Just like the other ones, you had to have 2 numbers. Well, here, you got to have 2 numbers. So we know that set the denominator equal to 0. That's your point of discontinuity. That's a vertical asymptote. But you got to find a number on them, so we set the numerator equal to 0. Now, you can't graph these. You can't draw these like you did up here. What you got to do, guys, is you got to pick some number from here, plug it in. Pick some number from this interval, plug it in. Pick some number from this interval, plug it in, and find out which interval makes this thing true. Okay? So, what would be an easy number to the left of 2? I would go 0. Wouldn't that be even easier? You can pick any. You can pick 1, that's fine, but I'm going to pick 0. If I plug 0 here, I have negative 6 over negative 5. What's negative divided by negative? A positive. Okay, so I'm going to put a positive right there to let me know that I get a positive answer when I plug that in. What's the number between 2 and 5? You can use anything. 3. Okay, so let's plug that in. 3 times 3 minus 6. 3 minus 5. 3 divided by negative 2 will give me a positive or negative. We're only worried about the sign. I'm not worried about the exact answer. Then I'm going to plug 6 in. And then 6 minus 5 is 1, so I know I'm going to get 12 divided by 1 is a positive value, isn't it? So, if I plug a number here, I got a positive. I plug in here a number, I got a negative. Plug a positive. This is less than 0, so what do you think my region is? The middle one right there. That's my answer. Because I got a negative number. Do you see that? Now, these are tricky because you can't just go back and say, oh, that was a less than, so I'm going to put a parentheses around these. No, these require more work. Let's talk about this. if I was to plug 2 into that, 3 times 2 is 6. 6 minus 6 is 0 divided by something gives me 0. Does it say or equal to 0 there? So what would you put around 2? Parentheses, because you don't want the answer to give you 0, do you? If I plug 5 in, it makes 0 on the denominator, don't it? Do you want 5? So what would the answer be here? 2 to what? Both around what? Parentheses around both of them. He said, Mr. H, well, you could just looked at that. Well, I'm going to show you how this one's different in a minute. I'm trying to get your mind to think like that. Set the denominator equal to 0. What do you get? You need another number, so you set the numerator. So that's going to be what? -5. Now, if you want to do this, guys, this might help you out. If you want to go and plug these numbers in to see if you can include them, it's fine. What's -5 plus 5? 0. 0 divided by anything is 0. It says less than or what? So if you want to put a closed dot to remind you that that is equal to 0, because I can include that, that will help you remember bracket or parentheses in a minute, okay? If I plug -2 in, I get 0 in the denominator. Can I ever have 0 in the denominator? So would I put open or closed? Open, okay? That might help you if you want to do that. If I plug -5 in, I get 0. 0 divided by anything is 0. It says it can be equal to 0, so I put a closed dot, meaning I can include that. All right, now, let's pick a number to the left of -5. What do you want to pick? -6. Got -6 plus 5. That gives me a negative value. -6 plus 2 gives me a negative. What's a negative divided by negative? Okay. I pick -3 here. -3 plus 5. That gives me a positive. -3 plus 2 gives me a negative. So a positive divided by negative is a... If I plug 0 in, I get a positive. It wants less than 0. So would you choose the positive or the negative value? So how would you write that? Bracket -5 to, and what goes around that? That's your answer. Yes, son?
So can you just plug in the numbers from the number line into the equation to figure out if it's closed or if
Yes.
it's not, and then use that in the equation? Or in the inequality?
Yes, that's right.
This set equals 0 won't always equal 0.
Yes. Unless, like it was in this case where it was less than, so they both got parentheses around them. Are there any questions on today's learning target? You have 10 minutes to work on your homework, which is 7 through 17 odd, page 41. Okay? Yes. Mark number 15. I'm going to get 15. And instead of doing 15, do add 16. Mark 15 out and just do 16 and 17. Yes.
I'll watch out for what you're doing.
Mark out 15. That's right. That's right. That's what you put. Yes. Very good. Guys, we're going to do 15 together tomorrow. That was a tricky little bit of skill. Like I said, omit it tonight. We'll go over that one tomorrow, okay? be all real numbers. Let's do that for me. Number 7's fine. Have y'all got to number 9 yet? Let's talk about number 9. Are we on number 9 yet? Okay, when you graph that, when you factor that, you get x plus 2 squared. X plus 2 squared. So you have a dotted negative 2. Would you go below the line? No. So what would be your answer to that? And what's the area less than or equal to 0? There's nothing. Did it go below that line? So what will be your answer? No solution. Because it did not go below that line, did it?
But
Yes.
if it's less than or equal to, wouldn't there be one? Does it touch the line?
No, that didn't go below. This is
But it's equal to 0.
equal to 0. You got a point there. So it would be just a bracket negative 2.
Okay.
Negative 2 in a bracket because it says or equal to 0. So the only solution would be that point at negative 2. Bracket negative 2. Good job, Ivy. Yes.
I don't know what the problem is, but the one with the bump on the board,
Mhm.
5, it does the same thing. It's equal to 0. I don't mind.
Got it. Okay. And guys, what happened on 15 that we're going to see tomorrow is when you factor it, you get imaginary roots. So that means it does not cross the x-axis. It stays above. So when it says greater than 0, the whole graph is bigger than 0. So that would be an all real number situation.
Do you want me to stop that recording?
Yes, please. Thank you, bud.
Can I touch it or do I have to use a mouse?
Just touch it. Let's see if it works.